through the test.
Me too. It's going to be a great doodle.
I'm hoping that you do the picture. I did it for the first year with the action potential graphs. I know it's gonna be a hormone.
Recognize that picture, folks?
Yeah.
That picture is on your test. I'm actually looking at the test right now. That picture is also in your book.
Yeah.
But notice, the picture on the test doesn't have the answers that the book has. It has numbers. I can ask you about all those numbers. In the lecture, when this picture came up in the lecture, I said to you, this picture is on the test, and now I'm showing you the test, and this picture is on the test. You with it? Okay, that's the only picture, so now I'm just going to sit here and go through the test and tell you what's on it, kind of in general. All right, so you have to know the big difference between the lipid-soluble and water-soluble hormones. Meaning, the water-soluble hormones, for the most part, bind cell surface receptors and act through second messengers. Lipid-soluble hormones enter the cell and bind intracellular receptors. Of course, any questions about that? There's more than one way I've asked that question.
Are you going to say lipid soluble, or are you
No,
going to say the?
you have to know the steroid hormones are lipid soluble. You have to know, for the most part, the amino acid derivatives are water soluble. The one exception is T3, T4.
Didn't you call them something else though? Hydrophilic and lipophilic?
Lipophilic means hydrophobic, and
Right.
lipophobic means hydrophilic.
Right.
I mean, they don't actually mean the same thing.
No,
Well, conceptually, they mean the same thing.
yeah.
Because if you're fat loving, lipophilic, then you're water fearing, hydrophobic. Okay. All right. You have to know the G protein, cyclic AMP, second messenger pathway.
The one from the video, where alpha detaches.
Yep. You got to know that one that I talked through quite a bit there, where the alpha subunit of the G protein detaches and goes and turns on adenylate cyclase, and that makes cyclic AMP, and cyclic AMP turns on this kinase, and blah, blah, blah. All right? So cyclic AMP and G protein, that's on. Okay, you absolutely have to know that the two hormones made by the hypothalamus but stored in the posterior pituitary are oxytocin and ADH. You have to know what oxytocin and ADH do. Oxytocin causes smooth muscle contraction, like in the uterus and in the mammary glands. ADH causes the kidneys to retain water. You have to know the three stimuli for hormone secretion. There's more than one question on this. What I mean by that is this. There's humoral stimuli, something in the blood, like high glucose causes insulin secretion. That's a humoral stimulus. Like high calcium causes calcitonin secretion. That's a humoral stimulus. All right. You have to know there's a neuronal stimulus for hormone secretion, like the sympathetic nervous system causes the adrenal medulla to secrete epinephrine. Like the sympathetic nervous system causes the kidneys to secrete renin.
What did you say that was?
Neuronal or neural stimulus. And then lastly, you have to know there's a hormonal stimulus to hormone secretion. Like all of those stimulating hormones going to their effector glands and causing those hormones to be secreted. Like TSH causing T4 to be secreted. Like ACTH causing cortisol to be secreted. All right?
So in one like hormone pathway, there could be a bunch of different types of stimuli.
Let me think. No. Like I can't think, I'm thinking of these pathways and they're usually one type of stimuli. Like, for example, High calcium causes calcitonin to be secreted. There's no other hormone that says calcitonin secrete. There's no nerve that says calcitonin secrete, so that's strictly a humoral stimulus. Low calcium causes parathyroid hormone to be secreted. I can't think of any nerve or hormone that causes parathyroid hormone to be secreted. All right? Although, there might be some of those pathways that have a mix of signals, yeah. But for the most part, I'm thinking of one thing only. All right? Okay. You need to know, well, of course, that picture on there. You need to know what a lot of these hormones do, obviously. And that was on the picture too. You have to know which releasing hormone for the which stimulating hormone for the pituitary goes to which endocrine gland, which hormones that endocrine gland secretes, and basically what it does. Yeah, like your lab sheet is a good sheet for that. That picture really covers the same kind of material. It's just a little different way of looking at it. Yeah. Okay, I already mentioned to you have to know what ADH and oxytocin do. I see it again. All right. Wow. Again. Okay, there's a question on here about primary or secondary diseases. You remember how in the lecture, we spent a lot of time in the lecture on this. Let me see if you remember this. So hypothalamus, pituitary, thyroid. Sorry, I can't spell very good. Okay. TRH, TSH, T4. Okay? Now, if I have hypothyroidism, what has to be low? Low T4. That's what hypothyroidism means, low T4. Now we're going to talk about primary and secondary. If I have hyperthyroidism, what has to be low? High. T4. And I'm going to talk about primary and secondary. Okay. So you would agree that with primary hypothyroidism, I have low T4. Right? Now, what does primary hypothyroidism mean? If it's primary, there's something wrong with the thyroid gland. There's something wrong with it. All right? That means the pituitary and hypothalamus are normal. There's something wrong with the thyroid. So I don't have hardly any T4. Is there any negative feedback? No. TSH will be high. Why is TSH high? Because there's no negative feedback and the pituitary is trying to get the thyroid to make T4. But the thyroid is broken and won't make it. Now, secondary hypothyroidism means that the thyroid is fine, but something else in this pathway is broken. I still have low T4, right? Is there any negative feedback?
Yes.
No, there's low T4. How can there be negative feedback?
Oh.
Now, if there's no negative feedback, there should be high TSH. But the pituitary is broken. There's low TSH. And the thyroid is only doing what it's told. It's making T4 because there's no TSH. The pituitary is broken and not making TSH. Secondary. Okay, would you agree with hyperthyroidism, you have high T4? Okay. So with primary hyperthyroidism, I have high T4. I have a lot of T4. Is there negative feedback? Yeah, there's tons of negative feedback. I don't have any TSH, or hardly any. Then why is the thyroid making all this T4? Because it's broken. It's making the T4 regardless of the fact that there's no TSH telling it to. With secondary hyperthyroidism, I have a high T4 by definition. There's a tons of negative feedback. There shouldn't be any TSH, but there is. Because the pituitary is broken. And the thyroid's only doing what it's told. It's making a bunch of T4 because there's a bunch of TSH. Do you see how these are 4 different clinical pictures in the lab or in the hospital? Annie, and I did that in the lecture too, I do believe. I'm sure I did, yeah.
I feel like
Rather than how I did in lecture? I actually did the exact same thing in lecture, but now you can talk to me.
maybe that's it.
But that, I mean, it's fine, I understand
Maybe because
that.
I'm hearing it for the
Yeah, I understand that. It's, you're looking at a movie in essence, and you can't interact. So it's not like you can ask a question. Questions about this? All right. So there's a question or two about this on there. Let me, I'm gonna go back to that picture. Because I want to, I've done questions on this picture, because I'm at the picture again, so I just want to talk about it. I've done questions on this picture as simple as this. Name the hormone label number 14, which by the way, is coming from the posterior pituitary, has to be ADH. How do I know it's not oxytocin? Because ADH goes to the kidney, oxytocin goes to the uterus and mammary glands. 14 must be ADH. All right, I've done questions like that. But I've also done questions like this. Which hormone is deficient in diabetes insipidus? ADH. 14. So 14 is deficient in diabetes insipidus. Which hormone is deficient in secondary hypothyroidism?
Oh, TSH.
Yeah, 4. 4. See, I've done questions like that on you too. And I know you're saying, well, okay, you're going to give me this big picture, then ask hard questions on it? Yeah. 'Cause that's what I do. You know what I do. So I'm making you connect the dots even from a picture, which is going to be hard to memorize in and of itself. So you must get this memorized and mastered, absolutely mastered. And then you got to go one step further and start making some connections. So I would say you have to master this and be able to draw this in your sleep and label everything on it. Because I'm not just asking you simply what is number 1, which is ACTH, by the way. I'm just not asking you that. I'm asking you something further that makes you know that number 1 is ACTH and makes you know something else about it. That's what I'm asking. Now let me get an example here. Oh, sorry, that was too fast. You couldn't have got all of it. She couldn't have got that. Yeah, I basically gave you some pretty decent examples already. All right, we'll keep going. Already covered that. All right, I didn't realize I did that. Did I tell you that you didn't have to know the 3 zones of the adrenal cortex? Or did I tell you you did have to know them? What did I say in lecture? You don't remember? Let me just tell you what the zones make. There's 3 zones to the adrenal cortex. The zona glomerulosa makes aldosterone. You don't think I did that in lecture?
No.
I did?
Yes, you did.
Oh. You are trying to
No,
fit
I
me.
don't remember.
The zona glomerulosa makes aldosterone. The zona fasciculatus makes cortisol. And the zona reticularis makes testosterone. Glomerulosa, now I went from outer to inner. I'm drawing. Oh, I remember that picture in the lecture now. I do, I remember that picture.
Yeah.
There's 3 layers to this adrenal cortex. The glomerulosa makes aldosterone. That's a mineral corticoid or aldosterone. The fasciculata, don't forgive me if I can't spell, makes cortisol. That's a glucocorticoid. And the reticularis makes, yep, adrenal sex hormones, testosterone, reticularis. Yep, there you go. I see that on the test. All right. I really did the renin-angiotensin aldosterone system in lecture. I did. Is it in your book?
Didn't we do that last semester?
Yeah.
Okay.
We do it both. I do it both semesters. Do you guys think that's fair game? Did I do it in lecture? Let me make sure it's in your chapter.
I was like, I remember you mentioning it, but I don't remember.
I'll do it again on the board if I didn't. If you guys don't think I covered it well in the lecture. I bet I did cover it well.
This thing right here? Yeah. It was a video.
Yeah, I was like, I remember that
It
now.
was a video on it in the lecture. It was a video that you showed us in lecture.
Yeah. Okay. I'm just gonna make sure it's in your book well too. Chapter 18.
1860.
Why are you throwing uteruses around, Sam? Here, you can go sit next to the penis. You guys belong together.
Right there. That's the adrenal.
What's that?
You recorded this?
Of
I
course.
said it's not by uterus, I had one ovary.
Really?
Oh yeah. He's there.
I shouldn't have
He's
recorded
on page
that.
641. I have a question on the renin-angiotensin aldosterone story on page 641. There's a question on the test. Page 641. Yeah, right there. That's the renin-angiotensin aldosterone story. By the way, it comes up again in the kidney chapter that we start after the test. So I'm actually going to post it. I was going to post it this week, but you guys probably don't want me to now because you'll be focused on the test. But I'll at least post it by Monday, the kidney stuff. You got to know for the kidney stuff anyway. Renin-angiotensin aldosterone story is on here.
Take your phone.
That's all right. I'm with you guys. Leptin is on here. And that's the last of my endocrine questions. All right.
That's a beautiful ring, tell me that though.
It just came with it. It came with it. Say again?
It's just so pretty.
Now, for the digestive system, I don't typically put a lot of anatomy on these lecture exams, but I see a question about the layers, the tunics of the digestive tract. Matter of fact, here's what it says. Put the following layers of the digestive tract wall in order from the lumen to the deepest layer. So I'm making you start from the lumen of the digestive tract where the food is. So that means mucosa better be first. And then I make you move deep into the body. So starting from the lumen and going deep, I make you put them in order. I talk about salivary glands. I make sure you know what deglutition and mastication mean. Deglutition and mastication. You hear me, Dave? I said mastication. It's chewing. All right, so I make it deglutition swallowing in case you guys don't remember that. I make you know how to make hydrochloric acid and what cells do it. All right, so you got to make hydrochloric acid. Parietal cells do it, in case you didn't know. I make you know the 3 phases of digestion. Cephalic phase, gastric phase, duodenal phase, intestinal phase, duodenal phase. Questions about that? All right. Matter of fact, let me tell you how I do it. Well, I gotta get rid of one of those questions. I asked that several times. Let me read it to you. Match the gastric phase on the left with the correct description on the right. So you gotta match the cephalic phase to the correct description. You gotta match the gastric phase to the correct description, and you gotta match the intestinal phase to the correct description. Let me read this question to you. Put the following steps of stomach acid production in the correct order, starting with the reaction that requires an enzyme. Which reaction requires the enzyme? Carbonic anhydrase. H2O plus CO2 yields carbonic acid. Carbonic anhydrase. All right? Carbonic anhydrase came up twice. It came up in chapter 24 and it came up again in chapter 25 when I told you it needed zinc. Actually, in chapter 25, I wrote carbonic anhydrase needs this mineral. And I reminded you what carbonic anhydrase did in the lecture. I drew out H2O plus CO2 yields carbonic acid. I did that in the lecture. So you've heard about carbonic acid twice now. You'll hear about it again. All right. You got to know these hormones: cholecystokinin, secretin, gastrin. That's the only one that I see so far. I mean, there could be enterocrinin in here, but there's only 3 I see so far. Okay, make sure you know those enzymes. Like amylase breaks down polysaccharide. Lipase breaks down lipids. The proteases break down proteins. Make sure you know them. Okay, you make sure you know the defecation reflex. How come babies can't control defecation? The internal sphincter is involuntary, and they don't have a well-developed cortical spinal tract. Their external sphincter is always relaxed. Exactly. Remember, what happens with us is when our internal sphincter relaxes, our external sphincter contracts. So how do we defecate? We have to consciously make a decision to relax our external sphincter. But babies don't have that. So when the internal sphincter relaxes, they defecate. Right in their diaper.
So the suspension of the right is what triggers the
Yep.
reflex.
Yep.
And then the parasympathetic causes the internal one to relax.
Well, remember, there's a short reflex and a long reflex, and it causes the relaxation. But the most important thing is this: in potty trained individuals, so from 3 years old on, you send down a somatic nerve to consciously relax the external sphincter. Where babies don't have that because their cortical spinal, their descending tract, somatic motor neuron is not well developed yet, so they don't have that choice yet. But yeah, it all starts with the distension of the rectum. All right, looks like I'm done with digestion. Now I'm on nutrition. I didn't ask you I did not ask you a ton of vitamins, but I did ask you this. I did ask you those. Niacin is a precursor of nicotinamide adenine dinucleotide. Riboflavin is a precursor of flavin adenine dinucleotide. And pyridoxine is necessary in the aminotransferase reactions. Okay, here's some good news for you. So I'm clear about something. I didn't go crazy in these control mechanisms on the test. If you've listened to the lecture, you probably thought I was out of my mind talking about phosphofructokinase for 10 hours. And I showed you a bunch of pictures that aren't even in your book. And I get that they're not in your book and don't have words to go along with it. But the point is this, memorizing metabolic pathways is not where it's at. I mean, I had to memorize them in undergrad, and you will too eventually. But where it's at is understanding how our body controls it. And I do expect you to know there's negative feedback controls for these pathways. Now, I don't even expect you to memorize every single negative feedback control for these pathways, like phosphofuctokinase has several. But I do expect you to be able to extrapolate some information from, if I give you some examples of, like if I say glucose enters glycolysis in the Krebs cycle, and some of our products are NADH, FADH2, ATP, etc. And I expect you to know that one of those might negatively feedback and shut down the whole pathway. And in fact, ATP does. ATP shuts down several of those enzymes. Because why do the pathways if you have plenty of ATP? I expect you to know stuff like, I expect you to know in general that we negatively feedback and shut it down. I don't expect you to know all the nitty-gritty details of what I was showing you. I do expect you to know this. How many ATP is an NADH worth? 3. So 1 NADH is worth 3 ATP. Go ahead.
I thought you went into that there was a difference between when it's in the mitochondria it's 3, but it's when outside it's 2.
Yeah, depends on what shuttle system you use, but yeah.
We're going with 3.
We're going with 3 because in the lecture I said, listen, if you use the glycerol 3-phosphate shuttle, it's worth 2, but if you use the malate aspartate shuttle, it's 3. And I just spelled those words out for you because I know some of you guys want to go look it up. I'm not testing you on those shuttles.
Okay.
But yeah, let's go with 3 because that's in general what they're worth.
Okay. No, I just figured I'm gonna go to answer that question, and the options are gonna be 2 and 3, and
It's 3.
I'll pick 2 because
Don't pick 2, pick 3.
Okay.
Pick 3. Because you make more NADH in the mitochondria. And in the mitochondria, they're worth 3.
Okay.
FADH2 is worth 2 ATP. Okay, that's in here. Let me show you another picture that I'm playing with. But I don't know how to ask it yet because I don't want you to memorize intermediates. So please don't memorize intermediates. Please do not go and memorize. I know you got pictures of this now, but I don't want you to go and memorize these things. But what I might do is fill in a lot of these intermediates and ask you some questions of it. This is the Krebs cycle, by the way. All right. But I'm not sure I'm even going to put it on there, just in case I want you to have a picture of it. Please don't memorize what 7, 5s, don't memorize what they are. All right. So I might give you a picture, but with most of the information filled in, I might ask you a question. All right? Yeah. Okay, HDL, LDL is on here. HDL and LDL is on here. I went into great detail about cholesterol is just cholesterol. There's no such thing as good and bad cholesterol. So why do we say LDL is bad and HDL is good, and explain it in the lecture? LDL takes cholesterol out to the body through the bloodstream. HDL takes cholesterol out of the blood and delivers it to the liver. So we call HDL good because it's removing cholesterol from the blood. We call LDL bad because it actually puts the cholesterol in the blood and delivers it all throughout the body. You have to know the urea cycle and why. Well, you don't have to know the details of the urea cycle. You just have to know there is a urea cycle, but why? And the answer is to remove ammonia from our body. Ammonia is deadly to us. All right? You have to know which hormones rule in the absorptive state. You have to know which hormones rule in the post-absorptive state. You should know that one of those hormones is in both. And here's how it goes. Insulin rules in the absorptive state. Insulin is the primary hormone. But growth hormone's there as well. In the post-absorptive state, the hormones that rule are epinephrine, glucagon, cortisol, and growth hormone. Now notice I mentioned growth hormone both times. Growth hormone is involved in both the absorptive and post-absorptive state. So the hormone that rules in the absorptive state is insulin, and growth hormones also involved. The hormone that rules in the post-absorptive state is glucagon, epinephrine, cortisol, and growth hormone. There's two things about cortisol and growth hormone that I beat to death in that lecture. I said it several times. Cortisol and growth hormone are glucose-sparing hormones. They cause you to burn other things like lipids and proteins, and they